All right, let's get some practice working with program distance. We'll just make up some data here to do this. Um, you can use the real data. I will have that up as soon as I possibly can. The first thing we need to do, however, is get the program onto your laptop or your desktop or wherever you're working from. If you're working at a university computer, I think that you can load it up onto a USB drive as long as everything is on that thumb drive, and then simply run it from there. So the first thing we need to do then is open up our web browser, go to Google and or Bing or whichever search engine you like to use, and then just type in program distance. And because of distance learning and online distance programs and whatnot, you'll get a lot of garbage up here. What you want to look for is distance sampling, distancesampling.org. So that's the web page. So you're going to click on that, and then under this odd little icon, click on distance for Windows, and that will enable you to download the program. So it's pretty straightforward. It doesn't require a lot of space on your hard drive. Is pretty straightforward to do. All right, the next thing we want to do once you have it installed on your computer is to actually use the program, and here you can see the icon right above this running person here. Just click on that icon, and that's showing up on the wrong monitor here. Let me move it over. I have to click an initial dialog box, that's fine, and move it over here where you can see it. Okay, so you begin with a blank screen like this. You're simply going to go up to the file and you're going to create a new project. Once you do that, it's going to ask you for a name for this project, new project. Just click create, and you then have a series of dialog boxes that open up, and you need to pay some attention to these. The first one here is going to ask you if you want to begin a new project or analyze data that have already been collected, and the answer there is yes. So you're just make sure that first radio button is clicked, and then click next. And yeah, right, I understand, right, you can read that. And next one, what type of survey was this? It was a line transect. There are other ways to do this, point transects and Q counts and things of that sort. If we were working with birds or with marine mammals, we would use some of these others. And although we had more than one observer, just to keep our lives simple at the moment, we're going to click the radio button here for a single observer. And then also we're going to click the button here for perpendicular distance. Now your data, you will click the next one, which is radial distance and angle. And what that means is that when you enter the data, it's going to ask you for the angle to the object that you saw, the dray or the squirrel, as well as the distance, and it will then compute the perpendicular distance. So I'm just making the example a little bit easier. And also we're going to indicate here that we have single objects rather than clusters of objects. There were a number of times when we saw multiple drays in the same tree. So in reality we would indicate clusters of objects here, and you can do that for your example too. So we're going to click next. Now an important dialog box here. Our distance measures were not in meters. We measured in yards. So we're going to indicate yard right there. Our transect was measured in meters, okay, because the UTM coordinates that we use, or the GPS units that we use, gave us UTM coordinates, and those UTM coordinates are in meters. And then what we want to do is we want to measure our dray density in hectares rather than acres, so we want to use metric. There are 2.6 hectares per acre, or rather 2.6 acres per hectare. Okay, so now we click next. We're not going to use any multipliers or anything of that sort. That's for a different sort of setup than what we've done, so we'll click next. And now it asks us if we want to proceed to the data entry wizard, and the answer is yes, so we're going to click finish. And it indicates that it can't open the help file. That's fine. Okay, let me move this over here. So now you can see what this looks like, and I'm just going to click next. Yes, and I have another, can't open the help file. Fine, whatever. Okay, we're good. So now we have fine, I'm going to click next. There we go. Next. And it doesn't like it that I can't open the help file. And every time I click this, it wants to open the help file. You won't have that problem because you will have a fresh, clean install of the program. So we need to click one more time here, and again, the help file, it's giving me a warning. Great, whatever. Okay, so now we're good. And one more time. Yeah, fine. There we, okay, and finish. Right, so now we come up with this window right here. We obviously have not entered any data, but we do have the structure of the data set embedded there. So now this is what we're working with, our new analysis, and what we want to do is click on this tab up here at the top where it says data. So you click on the data, and that then gives us where we started just a few moments ago. So let's click on these, and I'm going to move that bar over a little bit, and observation like that. So here we go. We're ready to enter some data, and let's pretend like we have 6 transects, and I'm going to give this, this is transect number 1, and it has, let's pretend like it has a length of 100 meters, so I'm going to click OK. I'm going to go over here to the ID section and right click on that and insert a record. And notice now I have a second transect, and that's transect number 2. We'll leave that at 100 meters as well. Let's add another transect, insert record. Now I have transect 3. Let's make that one 200 meters long. And I hit enter. Okay. Let's go back over here. I'm highlighting under line transect the ID. I'm going to insert another record. And we'll leave that one at 200. I'm going to insert another one. I'm going to make that one at 300. Hit enter. And then I'm going to add one more, insert record, and that one also is at 300. So I now have my 600 transect, or my 6 transects. And what I want to do now is insert some records. So let's go over here, ID. This is, I'm going to right click here and insert a record. And let's just say, well, let's do this. Let's simplify our lives a little bit. Let's put 10 or 15 observations on each one. So I'm going to insert another record. Notice what it's doing. I'm by putting it over here, you know, under the observation ID number, it's adding all of these observations within this very first transect. So I now have 6 observations within that first 7, 8, 9, and 10. All right, let's do the same thing for the next one. Insert, insert. So I want to get up to 20 here. It really is much easier to do it this way than to do these one at a time. There we go. Now let's do the next one. And let's do the next one. Let's imagine we only have 6 in this one. Now let's go to the next one. few more on this one. And just a couple more. And now let's go to the last transect here. And just insert a bunch. See, how many do we have? 58. Let's put a few more in there. Oops, let me go down here. Just a few more for grins and giggles. Okay, so we now have all of our observations, and now all we're going to do is I'm going to make up some numbers and just type in some distances and see what we come up with. So 10, and hit enter, 11, 15, 17, 80. Whoops, that didn't work at all, did it? 50, 40, 30, 22, 45, 0, 5, or rather, put another 0 in there, 4, let's do 31. I'm just making up numbers here. We'll leave that 0 in there, 5, 7, 19, 50, 20, another 20, 25, 30, 33, 22, whoops, 5, 11, 10, 10, 15, 16, 20, 20, 30, 19, 18, another, put 19, 10, 20, 16, 12, 10, 5, 5, 6, 6, 70, 13, 12, 10, 20, 25. Oh, that would be weird, wouldn't it? 20, 25, 0, 30, 20, let's see what we're doing here, 20, 20, 30, 20, 10, 10, 5, 7, 2, 0, 1, 10, 30, 33, and let's do 5. Okay, so now we have our data entered, and make sure I didn't do anything totally weird there. These are totally bogus data. We just made them up as we went. We'll use the real data that you collected out at Kapaa Park. We're ready now to run our little analysis. So what we're going to do then is go up over here, and we want to click on the analyses, and we're going to find the little running man here up at the top, and we're going to click the little running man. And it is now grinding away doing the analysis, and lo and behold, it gives us a green ball rather than a yellow or a red one. You'll recall that in class we came up with a yellow ball What's different here is that we had 6 transects, and the greater the number of transects you have, the better the statistical analysis is going to be. So now let's look at what these results look like. So we're going to click our little magnifying glass here and take a peek at what the analysis looks like. We can look at the inputs, we can look at the log, which is where we'll discover any errors and things of that sort. And then we can actually look at the results here. So you see these tabs on the right hand side. Let's go up here and click the next window, and we can go through all of these. We're not particularly interested in this. A lot of these things are of interest to a statistician, and if you're doing this in an effort to publish a paper, then you'll want to pay attention to this. But for our purposes in this class, this is the sort of thing that we're interested in right here. It is important, remember, that that this function be monotonically decreasing. So we're looking at only half of some sort of a modified normal distribution. Usually we've incorporated a normal distribution with either a sine or a cosine function to give it a nice shape here. And you can see here that it decreases monotonically. That means there are no places here where it increases suddenly. So not bad for an old guy just making up numbers on the fly. But at any rate, notice that if you're right on the transect, right, the probability of seeing the dray or the squirrel is not 1, and you would expect it to be 1. But this has this nice shape. Now recall what the purpose of all of this is, and that is simply that the farther the animal is away from the transect, the less likely it is that you're actually going to detect it. So if we're thinking about establishing the area or the distance around our transect that we're sampling, the farther away it is, the less likely it is to be sampled. So we're doing this in an effort to figure out what area are we really sampling when we're running these transects. Okay, so let's move on to the next one then, and still it looks monotonically decreasing. Oh, that does not look particularly good, right? And we come up with this result right here, and for these data, it gives us parameter d, which is our distance. Our point estimate is 10.327 drays or squirrels per hectare. And then this gives us the 95% confidence intervals, and based on the data that we put in, it's somewhere between 6.79 and 15.69, call it 15.7. So we're 95% certain that there are somewhere between 7 and 15.7 drays per hectare, which is the number that we're trying to get at. And of course those confidence intervals then allow us to detect if there are changes from year to year or from site to site. So if the confidence limits for one site do not overlap with the confidence limits from another site, then you know that those sites differ in terms of the density of the squirrels or the drays. Very good. So you're going to do precisely this, only you're going to use your data from that you collected out at Kappawa Park, and I will get those data up just as quick as humanly possible. See you next time. Bye.